Hello, we're back with exponential applications and talking about compound interest. And there's the formula. Once again, this time we're going to have to try to figure out what amount should we invest to have a certain amount after a certain amount of time. So here's the statement of the problem. Find the initial amount needed to have an account balance of $150,000 after 20 years in an account earning 6% interest, talking about APR, compounded twice per year. So what I'm looking at is kind of like a college fund, okay? Maybe in 20 years, that might not even be enough, I don't know. But let's just say it's gonna cost $150,000 for a bachelor's degree. And somebody in your family wants your newborn kiddo to have this college fund. So after 20 years, roughly, at 6% interest, let's see what happens. Maybe I should have done 18 years, or let's be hopeful, 16 or 17 years maybe. Okay, so let's plug in the information. I'm going green, I guess. So the amount after 20 years is $150,000. $150,000 is equal to the principal, the initial principal, the initial amount is what we're looking for that we don't know, that we would like to know. We've got 1 plus the rate is 6%, so that's going to be 0.06 divided by 2 because it's compounded twice per year. And all of that to the 2, there's my n times t is 20 years. Okay, so we've got p times 0.03, 0.06 divided by 2 is 0.03. Add that to 1, 1.03. 2 times 20 is 40. Alrighty. Divide both sides of this guy by 1.03 to the 40th power. 1.03 to the 40th power, and that gives us our P. Okay, let me just rewrite it the other way around with the P starting in front. 150,000 divided by 1.03 to the 40th, and let me punch that in the old calculatorus. 1, 2, 3, Taurus. Calculator, those don't go together. Maybe. 1.03 to the 40th power. All right. And we get about, woohoo, hi Chihuahua, about 45,983.53. 45,983. 53. Wow. Well, certainly 150,000 is a lot more than 46,000. So the account did, it grew the money, but wow, that's a significant initial investment. Let's try another one. Very similar. Okay, I'm just going to change one little detail here. Curious what happens. Da 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 da. Intermission music. Do 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 if you call it music. Da da da. Do 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 do. Okay. So I want to change one little detail I was saying. How about this interest? Let's just change the interest slightly. Okay. Let's change it to 10%. Just curious how this problem works out. Remember, we ended up with about 45,000, 46,000 as the initial investment, closer to 46. What if we had 10% instead of 6%? And we're asking the same question. So again, we put in the 150,000 for the amount that we want, the principal times 1 plus This time 0.1 over 2, all to the 2 times 20 for the nt on the top. Okay, this gives me p times 0.1 divided by 2 is 0.05, so I'm going to have 1.05 to the 40th, and that's equal to 150,000 on the other side. Divide both sides by 1.05 to the 40th. 1.05 to the 40th. This time I didn't use the parentheses, that's okay. And we get p is equal to this stuff over here, 150,000 divided by 1.05 to the 40th, which is about, okay, let's check this one out. 150,000 divided by 1.05 to the 40th. 21,306.85. 21,306.85 cents about. Well, wow, that's a lot less than 46,000. So what did we change here? We didn't change the time. We changed the interest rate slightly. We went from, well, okay, more than slightly, I guess. We went from 6% to 10%. We didn't even double the interest rate. And notice that the initial investment on our part was less than half of the 46,000. So pay attention to that interest rate. That's what compound interest is all about. You get really a lot of bang for your buck when you're compounding the interest. So of course, always shoot for the highest interest rate, and that will give you the most bang for your buck. So that's still a significant investment, but a lot better than our last one.